All right, so this is 2.4 day 3 notes. They're new this year, so new video. So we're going to start talking today about symmetry tests. So we've talked about things being symmetrical, or you understand that certain graphs are symmetrical. And we've talked about things like reflecting over certain axes. So if you reflect something over an axis, it's symmetric with respect to that axis, okay? So my type of symmetry, if I start right here, with symmetry with respect to the x-axis, and I look over here and I say, well, here is my x-axis, okay? If it's symmetrical with respect to the x-axis, what happens is that's going to flip over the x-axis. So it's going to look like this. And if I have a specific point on that point will be reflected over the x-axis. So if that's at 1, 3, my new ordered pair is actually 1, -3. Now we know what that picture looks like, okay? But what if I don't have a picture? If I don't have a picture, I'm able to test. So a test is something that I'm doing right on my equation, and I'm going to test for symmetry with the x-axis by looking at what changed here. My y values changed. So I would replace the y value in my original function with the opposite of y, or negative y, because sometimes my function starts out negative, so I have to think about this as being the opposite, not just negative, okay? And when I plug that in and I simplify, if there is symmetry with respect to the x-axis, then the equation remains the same as the original. You'll see what I mean when we actually do the testing, okay? But if I'm checking on the x-axis, I replace the y, because that's what changed on my picture. Same idea here with symmetry to the y-axis. So if I go over and look at my picture, here's the y-axis. And if I say that is my my mirror or reflection point, my picture is going to look like this. And I'm going to take this point right here, and it's going to be reflected over there. Well, what's that new point? Instead of it being -2, 4, it becomes a +2, 4. So in this case, what is opposite is my x values. So to test it, if I didn't have a picture, I would replace any x's with the opposite of x. And if I get back the same answer, if it's the same as the original, then I know that I have symmetry with respect to the y-axis. Okay. The last one is symmetry with respect to the origin. Remember, the origin is the ordered pair 0, 0, okay? So symmetry with respect to the origin actually does both of these things. So if I look at the picture, it's actually going to look kind of like this, okay? It's reflected, and what happens here is it changes both my x and my y. So this point down here would be at -3, -4. That's what happens when I have symmetry with respect to the origin. So I would replace both things, y with the opposite of y, and x with the opposite of x. And if when I simplify that, I get the same as the original equation, then there's symmetry with respect to the origin. So these are actually 3 separate tests, okay? And so to do these tests, we have to have an equation. So here's the equation I'm using. And oftentimes, guys, these are equations that we aren't familiar with. Like, I don't have that as a parent graph. I'm not sure what it looks like. So all I want to do right now is I want to test this equation to see where it's got symmetry. Okay, and I always have to show my work for this. So if I test with respect to the x-axis, I go way back up here, and we said with respect to the x-axis, I change the y values. They're kind of opposite. So my original function says x equals, so I'm going to keep the x, but then it says y to the 4th. So I replace the y with the opposite of y, so -y to the 4th minus -y to the 2nd. So my first step is I'm going to replace. But the next thing I need to do is I need to simplify. need to say, well, what would I get here? So the x stays x, but when I take a negative value to an even power, that stays positive. So negative y to the fourth is really y to the fourth. And the same thing is true here. So negative y squared is just y squared. And therefore, when I look at this, this is my simplified version. So the question is the result the same as my original equation? Is it? Yes. Therefore, it's symmetric with respect to the x-axis. Now, that only means it's symmetric with respect to the x-axis. I have no idea about anything else. I have to do separate tests, okay? So when I test for symmetry with respect to the y-axis, remember my y-axis means I change the x. So this time I'm going to replace my x with negative x, and I leave the y's as they are. Now when I do that and then I simplify, there's nothing to be done here. So this is like the opposite of x equals y to the fourth minus y squared. So tell me, is this the same as my original function? That's what I'm asking myself. The answer is no. So this particular equation does not have symmetry with respect to the y-axis. Again, that doesn't mean anything else about the rest of it. I actually have to do the symmetry test for the origin. What would I replace for this one? If you said both x and y, then you're correct. Okay, and sometimes you'd be surprised what you get here. So we're gonna replace x with negative x, y with negative y, and then we're gonna simplify. That stays negative x, this becomes positive, this stays positive. Again, I'm comparing this to my original, and the answer is no, they're not the same. So therefore, this particular equation only was symmetric with respect to x. But every single time you must show me that work, okay? Now, something else they're gonna ask us to do, and this is really a courtesy here, guys. We should remember what it means to find the x-intercept and the y-intercept of the graph. So any time that I have any picture here, right, any function, my x-intercept, boy, I don't know what happened to my line here, but that's okay. So every time that I'm going to do this, my x-intercept means that my y value is equal to 0. So I'm going to go with my new function right here, and I'm just going to say, well, 0 is equal to x squared minus 2. And I'm going to solve that. So to solve that for x, I would add the 2. So 2 is equal to x squared. And then I would take the square root of both sides. Careful. What do you get? You should get plus or minus the square root of 2. So that means that I actually have two x-intercepts. And those x-intercepts occur at the positive square root of 2, comma 0, and negative square root of 2, comma 0. Because these are the two x values that I get when y is equal to 0. Okay? Y-intercept. The y-intercept means that my x is equal to 0. So I'm just going to solve that. I'm going to say y equals, I replace the x with 0. Oops, it's a negative 2. So y equals negative 2. So that means that this is an ordered pair. There's only one of them. It happens at 0, comma, negative 2. So this is going to be very helpful for us in graphing quite a few things. So we need to know how to do that. Okay, then complete the graph. So what we're basically saying here is that I'm only giving you part of the graph. I'm basically giving you the part of the graph maybe where just my x is greater than 0, or over here I'm giving you where the y is greater than 0, or here I'm giving you where the x is less than 0. So I'm only giving you a part of the graph. And I'm saying, what would it look like if I finished the graph using the correct symmetry? So the first one says symmetric with respect to the y-axis. Well, remember, if it's symmetric with respect to the y-axis, that's sort of my mirror, and I'm changing all my x's to be negative, right? My x goes to negative x. So any one of these points right, are going to be like opposite. It looks like this. That would be folded over that y-axis and be symmetrical. Okay, in the second one, symmetric with respect to the x-axis. So here's my x-axis, and again, I'd be folding it over there, kind of changing what my y values are, and this is going to look kind of like that. And again, if this doesn't make sense, pick some points, right, where I can say, well, I'm just going to change my y to be negative or opposite, and then just kind of fill those in. All right, and then remember the last one, if it's symmetric with respect to the origin right there, it has to change both my x and my y. So my x's become negative and my y's become negative. So that one's gonna flip over twice. It kind of looks like that right there, right? And again, you could pick certain values and change it over the x and then change it over the y. All right, now symmetry is also a big part of even and odd functions, okay? And so it's kind of weird, but an even and an odd function does affect the shape of the graph. And functions could be even, they could be odd, they could be neither, but they could never be both. Now, the difference is if I'm testing for even and odd, I always do the same test. I'm always going to replace the x with negative x. Okay? And the reason is that even and odd functions only have symmetry over the even function would have symmetry over the negative x is the same. So hold on, I'm having a problem here. Yes, it would be symmetric over the y-axis, and an odd function is going to be symmetric over the origin. So I'm able to tell this right away. Okay, so if f is even, and I replace that, I get f of negative x would be the same as f of x. Then it's an even function, and it's symmetric with respect to the y-axis. If, when I replace x with negative x, I get the opposite, okay, that means the graph is odd, and it would be symmetric with respect to the origin. So this is a different test. It's a different way to show either one of these quicker, okay? So, last part here. It says, determine whether the function is even, odd, or neither. If it's even or odd, use symmetry to sketch its graph. All right, so let's start with this first one. F of x equals x to the negative 1 power, or I'm sorry, negative 2 power. First of all, I don't love this function as it is. I'm going to rewrite that. What does a negative exponent tell me to do? Push it down. That's correct. All right, so if I have this, y equals f of x equals 1 over x squared, and then I say, well, I'm going to do my test now. So I'm going to plug in f of negative x. That means 1 over negative x squared. When I simplify that, I get 1 over x squared. This is the exact same thing. That means that my function is even, right? When I plugged in a negative x, I got back just the same. So an even function means that it's symmetric to the y-axis. So I could fold it over the y. So generally speaking, what I do here is I'd only look at like points that I like 0 and 1 and 2, etc. Plug them in, which, by the way, turns out to just be, when I put in a 1, right, I'm just plugging in my values for this right here. And then I would use symmetry to flip it. Now, I just want to show you something here. Do you recognize this function? That's a parent graph. We already know what that looks like. You could take this deliberately right off of your parent graph sheet. Looks like this, but we already know this symmetry exists. So it's another way to look at how would I graph a function that looks like this. Okay, last part. We're going to test the second f of x here. That says 1 minus the cubed root of x. So if I plug in f of negative x, that's 1 minus the cubed root of negative x. Now, I need to simplify this. Here's the deal. Would you agree with me that negative x is the same as negative 1 times x? And then if I took that cubed root, I could break those up into what I would call the perfect cubed root and a non-perfect cubed root. So the cubed root of negative 1 is actually negative 1. So this whole function right now, the cubed root of negative x is really negative 1 times the cubed root of x. And if I copy the rest of this down, that's 1 minus that, which really means that I change that. So I get 1 plus the cubed root of x. So f of negative x equals 1 plus the cubed root of x. How does that compare to my original function? Is it exactly the same? No. Is it exactly opposite? No, because I have a positive and a negative. Here I have two positives. So this function is neither even nor odd, and therefore I don't have to graph this one. All right? So a little bit different ways to look at symmetry here. Your homework on this is going to be a worksheet, and the answers will be posted.